Why? Good morning. Thanks so much for joining me here in my shop. Now, at the end of the last video, I was left in a bit of a quandary about some capacitors that I removed here that someone else had inserted. And the quandary really developed around the fact that the schematic I've been studying doesn't match this radio perfectly. Now, there is another schematic that does match, so it's not really a big deal, but the one I was studying carefully did not match. And one of the things that didn't match is that these four terminals here are actually five. 1, 2, 3, 4, 5 terminals. The mystery fifth terminal, I think it's this one in the middle, is the one that had these spare capacitors connected to it. So here I've got some old parts I want to replace connected to a terminal, or that may have been connected to a terminal or involved with a terminal I could not find anywhere on the schematic. Well, I have found this terminal. So secondly, I kind of reached the conclusion because right in one of the diagrams in the manual, it calls this can a filter choke. But all indications are this is just capacitors. Well, I don't believe it. I believe both are in here. Because look at the size of this thing. I mean, what kind of capacitors would you put inside this huge can? Holy smokes. So I'm willing to bet there's a big transformer in here, or choke coil, and some capacitors. And now I'll just flip that around and say if there is a choke coil in there, I haven't found any connections to it. So maybe it is just one huge capacitor. Holy smokes. So, and the size of the capacitors that are in here are 2 microfarads, 4 microfarads, and as we're going to see, 6 microfarads. Now the capacitors I removed from the radio, just these two in parallel, and in subsequent testing this one appears to have no capacity, maybe because of a broken lead wire inside, or who knows why. Couldn't find any rating on it, but it does say electrolytic. Now this guy says 20, which is a very large capacitor. The largest capacitor I can find on the schematic for this unit is 6. And I think this guy is replacing the 6. So what I'm concerned about here is that somebody has used a clever technique to get around a serious problem that occurs in these radios that would normally require the replacement of this huge thing, which is not going to happen anymore, and somebody knows the shortcut. And that's what was applied. And that's what these are. These are the shortcut repair, or the repair technique that somebody had developed that would work without replacing this. And that's why this one lead is cut away from whatever this terminal is. So in my own ohm meter testing, I found this terminal to be grounded. There's a nice red dot up here too. Not really sure what the red dot indicates, but it's near this terminal. So in this radio too, the terminals are numbered 1, 2, 3, 4, 5. Of course, in the schematic I was using, there is no terminal 5. There's just 1, 2, 3, 4. So, okay, so I've got this sorted out now. We're going to take a look at the schematic, and due to some handwritten notes on the schematic that have come through in the copies that have been made, we're going to discover what's really going on with this. So this is the schematic that I've been relying on, and you can see there's an alternate one right down here. So this is what I've been studying here. There's another schematic I have on my computer that indicates, well, this one does, has the terminal numbers there, 1, 2, 3, 4. Now let's take a look at this. Over here, note difference in power pack. Well, let's go note the difference then. But right away, as soon as I look at this, I realize, this is really quite different from what's up above here. Looks like they've added in more filtering into the circuit. I also notice this resistor has been moved, and this one has been moved, and it now looks like one long continuous. Here, let me just move this over. one long continuous resistor, just like what's in the back of this radio. It up on this schematic it looked like a long resistor and another piece over here. So this one is also more pictorially correct for the unit I'm looking at. And it has some additional capacitors here. Let me get the other one on the screen here. So this has two capacitors, this and this. And this guy has two capacitors plus this one and this one. So if you look at the numbers here, we got C8, 9, 9, and 10. 8, 9, 10. So if we look at the parts list, and we look at 8, 9, 10, not that parts list, this one down here. 8, 9, 10, 2, 4, and 6. That's a total of 12. But the biggest one is only 6. And somebody stuck a 20 in here. And you know, to be really clear, what I'm wondering is, should I put a 20 in replacement of the one I took out? Or should I put something more in line with these values? So now here's the secret. After staring at so many of these schematics and looking around, my eye suddenly caught this guy right here. Condenser can, okay, that's the thing we're looking at. There's the terminals, 1, 2, 3, 4, 5 terminals, and here's a wiring diagram. Thank you to whoever put this on here. This explains everything. So we see pin 5 is the ground terminal, or the common terminal, let's put it that way, the common terminal. And then 1, 2, 3, 4 are just these different capacitors. That's all. In my unit, this wire is cut. This one here, this terminal is open. When I read this terminal, I read a short to here, or to the chassis. This is connected to the chassis. What this means is this capacitor is shorted. So the previous repairer got the wire, abandoned this capacitor, left the others in place, and then wired in an additional capacitor, 20 with a paralleled nothing. So it's still 20. So this is number 6. Well, this isn't number 6. This is 6 microfarads. 2, 4, 6, 4, and common. So there's the answer. So, okay, there's the answer. What's the question? The question is, should I put a 20 here? Well, let's think about that. If he's put a 20 there on purpose, his purpose would be to accommodate other problems in the radio. That's what I would think. And then these capacitors are weak or out of the picture also for some reason, and by putting 20 here, which would be putting 20 where? Where would 20 go? Oop, gotta go back. C, sorry. Yeah, C3. C, pin 3. Pin 3, C what? Doesn't actually tell you which capacitor it is. That's the 6. It's the 6, Jim. It's the 6 microfarad. Okay, 6 microfarad. C10. So it's this one right here. So conceivably what he's done is he's boosted this from 6 to 20. This is the second capacitor on the output, just beyond this choke coil. This has got to be in that can. So he either put a 20 there to compensate for weaknesses elsewhere, or he put a 20 there because that's all he had at the time, was an old 20 from some other radio or something. I don't know. Okay, so it's not really coming clear whether I should put a 6 or a 20 in here. So what would happen if I put, let's say I put a 6 in here, that's called for on the schematic. I put a 6 in, what would happen if it's not enough? Well, I think we'd hear some hum. I think that's about all. So to get rid of the hum, you'd up this from 6 to 10 to 15 to 20. And why would you hear hum if you've put in the proper capacitor here? This is designed to get rid of any hum. A couple reasons. One could be hum adjustments aren't correct, like this hum control. Possibly fooling somebody. I don't see how that, it doesn't matter how big you make this capacitor. I think if this is misadjusted, you're going to hear the hum. Well, I think the logical way for me to go on this is to put in what is called for. Put a 6 in here and see what happens. We'll put a 6 in, and if the set hums, we'll boost it and see what happens. But I think returning it to it, now that I know the can layout up here, the lead layout and the cans, I can test these capacitors. They're in circuit. Let's just take a look again. What circuit are they in here? So, is there possible for an ohm meter reading to get right around to the back side of the capacitors, or can I read across them? Let's just check them all and see what happens. But one of them was a dead short, the one that got replaced. So let's check them all. Okay, way to go. Finally, got some instrument work. Okay. So we'll clip onto the bottom one. We now know is in one way or another tied to the chassis. How do we know that for sure, Jim? Check it, baby. Check it out. Check it out. That's probably as good as a 0 there. Okay, any of these other capacitors blown? That's the question. Shorted. Shorted would be the word. That's not what I'm looking for. I am not looking for that. What happened to my theory here? My theory has been blown. So this one tests with a short. That's why I think that one's short. They're all testing with a short. There's one. Wow, okay, I thought I had a grip on this, but I don't now. So pins 1 and 2 show as a short to pin 5. According to that little can diagram, the set works, the set works, the set works. How can it work if these things are shorted? It really can't. Maybe the thing to do is to release these wires and repeat that test. How could this be a short and the set work? How could I get a reading of a 0, an absolute 0? Let's look at the schematic again and see if there's some way that could happen. So I was reading across, for instance, I had one lead here, and the other lead I was moving from here and here and here. There should be one more here. Be 1, 2, 3, 4, and a 5th. Yeah, they didn't number the terminals down here. Is that? I don't know. Okay, so, is there some easy way to see, like I read across this one, and I got a short. How can you get a short? You can't get anywhere back this way. You got a capacitor there stopping you. Looks like the only way to read a short here is that the capacitor is shorted. C10 is the one that we think was replaced. And diagram shows 2464. 2464. Two, 4, 6, 4. I'm thinking this is the 2. C8 2, C9 4, C10 6. 2, 4, 4, and 6. I'm reading a short. So this is the one that's cut away, leaving 4 pins to test. 2 of them test shorts. Oh boy. How can the set work with these things shorted? How can that happen? Oh my gosh, I'm totally paralyzed again. It's funny, eh? Right at the moment when I think I'm free to move forward, I become paralyzed again by questions. How can this radio work the way it is? It can't. It should have a short right in the power supply. Boom. Something would boom. This guy would fry. This tube was short. How can you have a short and still have the radio work? I don't know. I'm going to be asking myself that question for a long time, I think. Okay, let's see if we can get unparalyzed by looking at the radio. I don't know how this is going to unparalyze me. Holy smokes. Maybe I had this up on too high a setting. Let's try that again. So we'll read from there to there. Okay, so now we're reading a resistance. 1.5K. 1.5. Is that the capacitor? Take this away. Put it back on. I don't know what to make of those readings. Okay, let's try this next guy. Here we go. So I had the ohm meter up on too high a reading to see that there is actually some resistance here. So, whoa, what was all that? Now I remember making these before. 3500 probably through the capacitor. 3500. And this one, 1500 through the capacitor. The last one. Oh, there he goes. So now this is what I would hope to see. Something more like this. That's 10 megohms there. Falling. Wait a minute. And you test a capacitor, the resistance appears to go up. It starts with a short and goes up. This is coming down. Okay. And this one's right to ground. Correct? Yeah. Well, that might explain why the set works. Because these capacitors are not dead shorts. But they sure appear to be bad. Let's try a different instrument here. Let's put the brainy meter on it. Okay, brainy meter, what can you figure out? What do you say? I say it's a capacitor. 29 picofarads. What the heck? Come on. This is not at all what I was expecting. It's exactly the same. 29 picofarads. V loss 0. Wow, this stuff's not adding up at all. Not adding up. Next one. Ooh, it's taking its time here. I think that means it's a big capacitor charging. I think. Ooh, this is the longest. There we go. 28 picofarads. Jeepers creepers. What if now this terminal appears to be shorted to the chassis. What if I ask it about that? Oh, you brainiac if you've fallen off here. Okay, smart ass meter, what do you say now? Get that little brain going in there. Resistor. So that's basically telling you it's shorted. It's picking up a small resistance. Just be leads or something like that. Let's go here. They didn't make this meter with old radios in mind, that's for sure. Okay. This is 5,000 nanofarads. Okay, think about this. 5,000 nanofarads is 5 microfarads. That's interesting. The ESR is 1/4 of an ohm, and there's a loss in there. So you don't really know exactly how to interpret these numbers in these old radios. That's interesting. So we got kind of a decent reading on this pin number 4, and it was 4642. So we're reading. Oh, come on, really? We're reading. We're reading 5 where it's supposed to be 2. Oh my gosh, it's just all over the map here. Well, I gotta go away and think about this some more. What I'm anxious about here is making a mistake and causing damage to this radio. I'm very seriously concerned that I could misinterpret something here. There's something I don't know. There's no doubt there's stuff I don't know. And if I just do what seems obvious to me right at the start, which I've done many times in my life, only to discover what's obvious sometimes is just not right. So I'm going to stop at this point and ponder the situation before I go any further. In fact, it's a beautiful day. I'm going out to do yard work. Honestly, that's what I'm going to do. So I think we got to stop at this point and think some more.